Hi everyone, welcome to this video on lesson 5 of the Earth and Climate scheme of work. This one is on weathering and transportation. I realised in the previous video the really important thing that I forgot to mention was that the lesson on igneous rocks was an introduction, really the first glimpse students have had of the rock cycle. So I've sketched the rock cycle here, and you can find probably better diagrams on the internet which you can share with students, but if this is the rock cycle here like this, then what we're doing with the rock cycle is, the reason this is helpful is because it shows how everything that students learn about relates to one another. So we're not just asking them to remember arbitrary facts. Okay, igneous rocks, crystals, sedimentary rocks, fossils and layers. Metamorphic rocks can be wavy. What we're doing is giving them a scheme that shows how igneous rocks, sedimentary rocks, metamorphic rocks, and so on all fit together, to help them remember why these different types of rocks have these different features. So it's really, really important that throughout this next sequence of lessons, there's kind of 4 lessons really on the rock cycle, plus one where they pull it all together and do an extended piece of writing. It's really important that throughout these lessons, we are constantly going back to the rock cycle and showing how all of these seemingly disparate ideas actually fit together in a coherent story. So what we did in the previous lesson is we looked at igneous rocks and the fact that another thing I forgot to mention is the idea of extrusive versus intrusive, but hopefully that was clear from the slides. But anyway, the idea that in the previous lesson, in igneous rocks, magma rises, and depending on how fast it rises, that determines how fast it cools, it determines how large the crystals are, and then we can see that in the structure of the rocks that we actually see before us. What we're going to do in this next lesson is talk about this stage here. How is it that we move from kind of larger rocks and rock formations and outcrops to the kind of smaller rocks that you might see in sand, and even not even rocks, but like grains of minerals and stuff. How is it that we get to that? And that's going to lead us into the next part of the story in the next lesson, which will be on sedimentary rocks. So we're going to zoom in on this part here, and I've sketched this out here in my book as follows. So yeah, one thing that's hard here actually is that students might get the impression that only igneous rocks are being weathered and broken down, and I'm not sure how to do this. It's a while since I've actually taught this to students, but we need to make it clear that many rocky outcrops are outcrops of sedimentary rocks. And again, this is where it's hard. What do we teach first? It's all a bit chicken and egg. But anyway, we can give them a simple story. And really what we're doing here is outlining 3 main ways that rocks can be broken down by what we call weathering. So we can start at the top of high mountains with boulders that look like this. And it's important that we're at the top of high mountains because at the top of high mountains, again, we can go back to atmospheric pressure and how pressure relates to temperature and so on, but essentially the point students need to understand is at the top of high mountains it's really, really cold. It's much colder at altitude than it is down at sea level. So if we zoom in on what goes on here, we can show the first of our types of weathering, which is freeze-thaw, which looks like this. And all I'm going to do in this lesson is just give some really, really simple accounts. They will learn about this stuff in geography as well, so this is really a linking lesson, but I think it's helpful to complete the story. And we can say in boulders like this or rocky outcrops, rainwater can settle, if I can find my blue pen, rainwater can settle in cracks or any available parts of the rock like this. It can settle there, and then when it gets to nighttime, at high altitude, nighttime especially, or in winter time, this rainwater freezes. Now this is one of those things that's quite hard for students to get their head around, and I couldn't tell you off the top of my head exactly why this is. It's something to do with hydrogen bonds probably. But water is the exception to the rule. Most substances contract when they freeze, but water expands when it freezes. So we can label it like this, and again you may wish to add a label of expand here if you wish. I'm just going to leave it like that. But as the water freezes, it expands, and what that does is it can kind of cause new cracks to form into the boulder. Now, if this happens multiple times, then water gets into the next cracks and so on. And what we eventually get, if I draw this like this, we get a kind of bigger crack starting to form like this, and it's still happening. So I can draw my water in here. It then freezes, it expands, the cracks get deeper. So the cracks get deeper and deeper like this, until at some point, this poor old rock just splits in two. We can label that here like this. It splits in two, and I can add some labels to show that it's splitting like this because of this repeated freezing and thawing. So this is what we call, it's an example of physical weathering, but we call this freeze-thaw. So that's the first type of weathering we can draw students' attention to, and just give them an illustration of how that happens. So freeze-thaw is one way the rocks can be broken down into smaller ones. Now they can then be transported. So transportation is something that kind of happens all the time anyway. Different ways they can be transported, but one way is by gravity. And again, so I'm going to draw students' attention to that. I don't necessarily need to write it, but one way is by gravity. They can just fall down. And maybe you could illustrate this here, and it's not obviously quite as clean cut as this. Maybe this is an oversimplification, but now we can say we've got some smaller rocks. So then we can look at some other ways that rocks can be weathered. So let's have a look here. So one other way the rocks can be weathered, my box a bit neater, is by what's called chemical weathering. And if you want, again, this is more like geography, but you could sort of say, well, warm air rises, it goes to mountains, so we've got some rain happening here. And the point about chemical weathering is that rainwater has some acidic substances, things like carbon and sulfur dioxide, which can settle in the cracks. So if I draw a little rock here with a crack like that. So if rainwater settles in the cracks, well, it can start to react with the minerals in the rock, and it just starts to kind of eat away at the rock by that reaction. So that what happens is, over time, again, we get these deeper cracks forming in the rock, which continue to fill with rainwater. And this continues to happen until, again, as we saw in the previous example, that rock can split. And you get these really characteristic rock formations where this happens, the karst or limestone pavement. I grew up near the Yorkshire Dales, and there's lots of limestone pavement there. You also get it in Slovenia, bits of Portugal, other parts of Europe as well. So that one is another example, and this is what we call chemical weathering. So I'm going to illustrate that to students like this. And then the last one that we could draw their attention to, maybe we could show as we're getting lower down, now we're getting more vegetation. I've lost my green pen. I'm going to add some trees in here. So maybe we can illustrate this by adding some trees. So now we've got some trees in this part of the landscape. Boulders around here, maybe near a waterfall like in one of the examples in the slides. I can illustrate the last form of weathering like this. So what you get down here is where if you've got cracks from freeze-thaw or chemical weathering, or maybe small cracks, then the roots start to grow through small cracks like this, and they can make those cracks wider. So if I draw a tree coming up like this, then its roots start to go down like this. And again, what that does is make the cracks get wider, and so that ultimately the rock gets split into smaller pieces, which we can like this. And that one is called biological weathering, as you've probably already guessed. So that's what I'd illustrate to students by. My brain is going dead. Biological weathering like that. So these are the three types of weathering. We can talk about this. I mentioned a waterfall here, so we can talk about the other ways that rocks can be transported. So also by water, by the wind, by ice in glaciers, things like that. Again, that's maybe more the kind of stuff that they cover in geography, but you can mention it and it's important. The last thing to say that I think is really, really important here is that there's no kind of hard and fast rule about this, because you do get boulders down at sea level as well. But one thing we can say is that what this whole process does, the kind of breaking down of rocks by these three different methods as you go down, it means that as we get to the beach, what we've got is lots of very small grains. So rather than kind of big boulders, even though there are some big boulders there, of course, but this breaking down of rocks means you get sand and other kind of smaller bits of minerals down towards sea level, and that's going to be really, really important as we look at the formation of things like sandstone and to a lesser extent limestone, but certainly sandstone in the sedimentary rocks lesson, which comes next. So if you emphasize this kind of this change as rocks are weathered and transported, and maybe I'll add one more to do with water, and you could mention ice and wind as well. That's going to tee the next lesson on sedimentary rocks up really nicely.